Have you ever seen a cruise ship full of people partying and wonder, dang, that looks heavy. How is that thing not underwater yet? Well, I have too, and it all comes down to this little thing called buoyancy. Hey, I'm Nakki with some food for thought, and today we're exploring just how these heavy ships stay afloat. Buoyancy or upthrust is basically a measure of an object's ability to float in a fluid. How buoyant an object is depends on two things: the volume of the water displaced by the object and the density of the water relative to the object. By maximizing both of these quantities, we can increase upthrust to be greater than the weight of the object. This is basically how things float. The volume of water displaced by the ship is equal to the volume of the part of the ship that's underwater. This is the Archimedes principle. Yes, the Eureka guy. If the amount of water the ship displaces has a greater mass than the ship will float. So that means by changing the mass of the object per unit volume, which is the density, we can make sure it weighs less than the water it displaces. So how do we do this? Let's take a look at the equation for upthrust. It's the volume of liquid displaced multiplied by the density of the liquid displaced multiplied by the gravitational constant. Imagine you have a 1 by 1 by 1 meter cube of metal. This is going to sink, but what if we made it longer and flatter without changing the volume? Hooray, now it floats. But why? It's got a wider surface area, so more force is being applied to it by the water for it to stay afloat. But we can do better. Let's say we make the box hollow, filled with air instead of dense metal. Now, even if you push the cube underwater, it'll float right back up to the surface. Congratulations, you've just invented a boat. Essentially, what we did is increase the volume displaced by widening the surface area and decreasing the density of our boat to be, so the density of the liquid is higher in comparison. Ta-da! You've got max upthrust and a ton of happy cruisers. Fun fact, this is also how hot air balloons fly. The air inside the balloon is heated so it expands, taking up more volume per unit mass, so it has a lower density than the air surrounding it. That's why hot air rises. The balloon then floats in air, much like the metal does in water, and the heat of the air is controlled to move the balloon up and down whenever necessary. So the next time you get on a cruise ship, you can take a break from all the partying and thank buoyancy for all its hard work. Thank you for listening. I hope I fed your hungry brains. See you next time.